Thank you.
Welcome to the Astro Cafe for October 7th. And I'm hosting tonight. In the order of just when we actually got people mentioning things, I've got Randy talking about the comet to start with. So,
Okay, so you'd like me to start the proceedings? Sure. Let me share my screen. Share. And
Thank you.
F5.
Sit here.
Good.
It's good.
Very good. And Kevin, can you hit that okay up there? Okay. So I would like to talk this evening about the comet that is gracing our skies this month. So there really are some wonderful photos out there in the intertube. This is from Brazil with the moon. Here from Namibia. Isn't that spectacular? I don't know what the blue tail is versus the various elements of the white tail, but maybe somebody knows their comet anatomy better than me.
Yeah, ion jet.
But one's ions and one is
I think it's plasma or something like that. Well, actually, I think the white one is just like the sublimation, the ice and dust.
Blue one, that's the ion trail.
but then there's that other
Solar.
white one going up.
Yeah, I'm not sure about that one.
Anyway,
Well, there's solar winds affecting which one, the ions or the tail?
solar wind's doing all of them, but the ions have lower mass, so they go straight away from the sun, whereas the dust includes their own velocity.
Mm-hmm.
Anyway, these are from the southern hemisphere, and it's because it's in the southern hemisphere. But let's talk a bit about the discovery. So Atlas. So it's called C2023A3 Tsuchinshan-ATLAS. And the Atlas comes from this lovely backronym, Asteroid Terrestrial Impact Last Alert System. So great acronym, I guess. Anyway, it's a very fast half-meter telescope that is set up just to look for asteroids, and it found this magnitude 18. That I haven't read closely about it, but the way that these observatories do it is that they take a couple of images 4 hours apart or so, and they're in the bottom, that fuzzy thing there. It doesn't actually move, but the fixed stars around it do move. So like you see those two stars there, that's these two stars here. And the fuzzy thing over the few hours between these two pictures made that move. And they said, okay, we've got a target. And they did some calculations and they said, oh, look at that. This has to be the same as this planet that was discovered on January 9. And Tsuchinshan means purple mountain. Mountain is Shan, so the Tsuchin must be purple. Anyway, they had discovered something similar, but then nobody followed up on it. It just wasn't, nobody saw it again. And so by the 30th, they removed it from the catalog. And then on February 22nd, it went back in the catalog. And then, so it got them both names, Tsuchinshan for the original discovery and Atlas for actually, giving it the data you need to work out the proper trajectory. So the other thing is the C2023A. C stands for comet, but not all comets are called C. You also get P comets. Hold on. Sorry about that. And the C refers to comets that have periods of greater than 200 years. The other ones are periodic comets, and so P1 is Halley's Comet, for example. And then this 2023 means it was discovered in the year 2023. And then they divide up the calendar into 2-week bins. So A is the first 2 weeks of the year. It's very handy, 52 weeks a year, 26 letters. So you go from A to Z every year. And this was the third comet that was discovered in the first 2 weeks of September. Okay, so that's where the name comes from. And as I was saying, this is an extreme blow up of the inner portion of the trajectory. So most of the time it's going to be way out in the Oort cloud, past all the trans-Neptunian objects and everything. And then it came in to visit us, and now it has gone into the southern hemisphere past perihelion in September, and right now it's around here, very close to where you look at the sun. And so that's why it's very tough to see right now. But soon it's going to get far enough away from the sun, but close enough to Earth that we're going to be looking at a pretty bright object. Okay, so this is from COMS, the Comet Observation website. And this is Comet 2410 for whatever reason. And I put lots and lots of lines. It's a lovely website, and you can actually, say what dates you want and all the lines that you want. So let's go through these. So first of all, this dotted line, that is how far the comet is from the sun in astronomic units. An astronomic unit is the distance between the Earth and the sun. So you see, it's much, much closer to the sun than the Earth is. It's down, I don't know, somewhere around 0.5. It's something that somebody could look up. And perihelion was on September 27. Leslie needs to pick up his cookies. Go for it.
They stuck together. I had to take 3.
So then you see these dashed lines around it, and it goes down and up and down and up. That is the distance to the Earth. So for half the year, it's a bit closer than the sun, and half the year, it's a bit further from the sun. And you see right now, it was the brightness, that's this blue line. It leveled off for a while, because even though it was getting closer, the Earth was further away. But now it is closer to the Earth. And on, it's hard to say what date it is, but something like the 13th of October, we will be at perigee, closest to the Earth. But it's getting further away from the sun now. So you have this battle between the comet will be brighter as you get closer to the sun, but it's so it's getting away from the sun, it's getting less bright in absolute terms, but it's getting closer to us, so it's getting brighter. And the ratio, the optimum is going to be something like October 13th. That being said, you can never predict with comets, because they never actually behave. But you do see, well, let's go, this is just a blow up. This is what, I just went back to September 21, and you can see that it is far exceeding the expected curve, the one that they thought it would be a long time ago. I think part of that is when the comet is between you and the sun, then there's something called backflow, something like that. I'm hoping that There's some people who know their comets better than me. And so the comet gets brighter than if it were just a simple object that's reflecting the light of the sun. The dust, when it gets the light from behind, glows really bright. But you see, there are a couple of measurements that are up in the 0 point something. So that's around here. And a zero magnitude star is bright. On the other hand, it's right at these images were all done in the morning, just before dawn. And so you're fighting the sun's glow in the atmosphere. And Alex, you just told me that you gave it 2 tries this week at 5 in the morning.
A week ago, I was at Cattle Point. I was there at 5 o'clock in the morning. I tried to find it, but it became cloudy, and I thought I saw a streak. Not that long, but I couldn't see it anymore. I just saw a glimpse of that, and I don't know if that was what it's supposed to be.
Oh, maybe it was it.
I don't know. And then I went on the Wednesday, not this coming Wednesday, the last week Wednesday.
And
Nothing. It
Nothing.
was clear. It was clear, and there was someone there who had the app who said no way, box me where. So I was just looking at there. There was less clouds, but there was the glow of sunrise.
Right.
yeah.
Plus a fog bank.
The fog, maybe, yeah.
So Bob King is with Sky and Telescope, I believe, and he put together this little animation. And you see it's really close to the sun now, and will only be seen, by, well, one of the things they say is SOHO, the Solar Observatory in space, will get some nice views of it. So we could look for it with that. Without the atmosphere, you can see things very close to the sun. But it's only somewhere around the 11th that it's far enough away that you get a chance. But there's this other cool thing. So somebody, Nicolas Lefadeux, has some way of modeling what the tail should look like. So he actually gives 4 times a day, and it's a bit boring. I just chose midnight universal time. So that would be just around dusk here, a bit before each day. So here we are, September 30, October 1, October 2, October 3. There are some measurements in October 4. I think by the 5th, nobody is really seeing it. 7, 8. That is the minimum distance. Half an AU. Elongation is only 4 degrees. So it's only 4 degrees from the sun. The sun is half a degree. So 8 suns away in diameter. But now watch this. This is super cool. So that's the 9th. The 10th. So it's still, even though, so we would see it now just after sunset, but we would see the tail kind of pointing towards the sun. And on the 11th, it's still kind of pointing towards the sun. There is the ion tail going away, but the dust tail is going towards the sun. And the white thing underneath, that's called the anti-tail.
Randy, at the suitable moment, I've actually got the diagram that shows the anatomy of the comet.
Oh, great. Okay, so let's do that after my presentation. I'd love to see it. And then what happens on the 12th? It's just wild. Anyway, so there's this big transition, and then one day later, then it really swings around. That's the 13th. And by the 14th, then it looks like a normal comet, but with an anti-tail. Again, this is a model. There's no reality here. This is this guy's model. And 15, and that's it. So there's this guy in Britain, Stuart Atkinson, who made this really nice series. He's a big astronomy outreach guy in Britain. So just the general rule for how to find the thing. So first of all, get out there around sunset, and the sun, you know, we're after the solstice, so the sun sets a bit south of west, right? In the summer, it sets north of west, in the winter, it sets south of west. We're just past the solstice, so it sets a bit south of west. And then hopefully at some point you'll be able to see the Big Dipper and follow the arc of the handle. You arc to Arcturus, okay? And then if you're looking on the 12, 13, 14, you kind of keep going in that line, and that's where you'll find the tail. And then it's going to get very dim, and you're going to have to know where it's going. One more picture, again, follow the arc to Arcturus, and then keep going, and there we are, 12, 13, 14. Are we going to see it this dark when it's still above the horizon? I think that's wishful thinking.
It's also full moon on the 17th, but on the other side.
Yeah. it's
Yeah,
okay.
yeah. The moon doesn't disappear in about the 20th, actually.
Yeah, I think the sun is going to be far worse than the moon in our trouble.
True.
And I'm just going to finish off with one absolutely glorious picture from Australia not too long ago.
That's a big tail.
So again, I don't know what magnification this is at, but I think the text said something like a 20-degree long tail. And bright enough that you could see it over the city lights.
Yeah, that's actually quite a long tail.
Okay, so David, share your
Yeah, so we were asking about the anatomy of the comet. So I found a NASA site that explains it. So this is one of the kids' NASA sites where they explain what things are. So there's the ion jet, and you'll see this. You remember when Randy was showing the simulations, how the tail is actually shifting? Well, that's shifting in response to the sun. And this white area was the dust tail. This is the sublimation part, and the big head, of course, is the coma, and the nucleus. So it's a simplification of what the comet looks like.
So is the dust tail, it doesn't follow the comet's orbit, but is that because the solar wind is also pushing it off the
Yeah, I think the ion tail appears to be the thing that's really affected by the solar wind. Based on the thing.
the ion tail is directly towards the sun.
Yeah,
because
exactly.
they're fast.
yeah.
Whereas the dust tail is the speed of the comet and the speed that these dust particles are going back. So it's like when you take your hose, it looks like an arc going back because you're spraying it. The where it says dust tail left
Yeah. So
the comet yesterday,
Mhm.
and the comet has moved to there today because the dust is going much slower.
Well, the dust is presumably orbiting at the same speed as the comet.
But it's moving out. It's moving away from the
Yes, and then
sun
it's slowing
because
down a little bit,
because of
but
the
it's
solar
also
wind.
being affected by the solar wind, so
Yeah,
it's speeding
pushing.
up
It
in
is
that
pushing.
direction.
Mm-hmm.
Does anybody have a good weather prediction for next week yet?
No, we don't have. Well, whoever's a meteorologist maybe chime in.
It's gonna be cloudy.
It's gonna be
Thank
cloudy.
you. Just a principle.
Yeah.
Yeah,
It is Victoria.
Yeah.
Yeah.
That animation you showed of when the comet was passing in front of the sun, would it be bright enough with the backflow for it to be observed with a solar filter? Or was the sun would be too dominant?
Who's going to answer that? I think you don't have a chance.
Yeah,
Yeah.
we could try.
Just for comparison's sake, last night when we were at the DAO, we actually saw the crescent moon setting, and we could also see Venus at around 7:30. It was certainly dark enough. I mean, Venus is bright anyways, but yeah, we could really see Venus. It was in the gully of one of the distant hills, and I looked at the heights and then compared them to the heights of the comet, and the comet's above those areas, so there's quite visible actually at
And what magnitude is
7:30.
Venus these days?
It's probably in a 1, not more than a 1, I don't think.
Hmm.
I'll have to have a look, or a -1 maybe.
Somebody can pull up their stellarium.
Yeah, somebody can probably. Yeah, what's the
We have a
brightness
good
of?
chance of having it in the zeros.
Oh, that so brighter than Venus.
We have a good
Yeah.
chance.
Wow.
Don't
Well,
ever hold your breath with a comet.
Yeah. But just from contrast's sake, like I've been tracking Venus all summer, and I would wait for the sun to go down, and then I would look for it. And it usually took me like 5 minutes past the time that the sun disappeared before it became, relatively apparent. But wouldn't you say, Kevin? I mean, you were with me most of the times.
Yeah.
Like it would take 5 minutes, and then I would take a really wide field eyepiece and just kind of peruse around, and then eventually I would spot the spot, and then of course you wouldn't unsee it at that point once you saw it.
Yeah, David, the night I was with you on the hill, it was funny until you could point out where it was invisible.
Yeah.
You couldn't, every time you looked, it was like shining so bright.
Yeah, I mean, the trick I always use is I always use a kind of a really wide field eyepiece, like 6 degrees or something like that, right? And then when you're scanning, it's pretty hard not to see it eventually. Once it dims down enough, you can see it.
I have a question. How is a apparent magnitude of a diffuse object like a comet?
That's a good question.
What does that mean? Is it you put it all together in one single point like a star, and that's the apparent magnitude?
I think when it's diffuse, it's not as bright as you think it is. I think that's the way it works out.
Yeah.
Yeah, it's basically
It's
the
somehow
brightness.
an
of the
aerial brightness.
Hold on, Dave.
It's just the brightness of the object. It's actually a log scale. So
Well, I understand that. I'm
But
talking
is
about
it the integrated brightness?
Well, it's spread out for a
The
diffuse
surface.
object. It's actually
Yeah.
spread out over an area rather than a single point, right?
So what
Yes.
does that mean? You mean to say that it's as if you brought the diffuse area together and that's the apparent magnitude equivalent to a star? Or is it something,
well, even stars aren't a single point, right?
well, they're effectively a single point.
Well,
Our eyes don't have enough pixels to pick up the size of a star.
sort of. But it still has a radius. So if you went in and did a surface integral over the
Diffuse object. I mean, Dave is right. Like stars, at least photographically, stars are not single points, right? I mean, there's an airy disk when you use optics, and it ends up being a certain size depending upon your sensor and the focal length of the optic. That's right. I got that right, haven't I, Brock? Or
there is a flux that comes off the star too, which is the flux at a certain point. Right? But you have to integrate the flux over this entire area.
I think Susan has a hand up.
I don't see it on the. Oh yeah.
I just wondered, when we're looking west, if the sky's not too cloudy, do we look low or high?
It
On the
depends on the
horizon.
day. It depends on the day.
Well, Thursday or Friday.
It's still pretty low
Okay,
down. I mean,
Thursday, you don't really have a chance.
Yeah.
It's still going to be
Oh, really?
too close to the sun. So
Very
the
low. Very
The
low. I would
earliest that you're
suggest you
expected to
get,
see it is
So I should
something
go up
like
Mount
Sunday.
Palmiers. Pardon?
The earliest you should expect to see it is on Sunday, and even then it would be very low.
Yeah.
So I should go to a high point, like up Mount Ptolemy, or I should go to the ocean.
Well, yeah, you need a low horizon line, like a sea level horizon
Yeah.
line. That's what you
Okay.
need
Okay.
in the west,
Cool.
because
in the west. Yeah.
Yeah.
and you have to observe it right as the sun is obscured by the horizon.
Right.
Okay.
We're
Thank
just
you.
talking minutes.
Yeah, you don't have a lot of
Oh.
time. It's
Oh.
just like sighting Mercury. You don't have a lot of
Oh.
time. You got like
Oh, all right.
15
Okay.
minutes or something like that.
Good
You might
excuse to
have-
go to
You might have a
Tofino.
better chance of seeing the tail if what the photographs from the southern hemisphere are telling us
Hmm.
are accurate when it's visible from here.
Yeah, I mean,
I don't-
I plan to just kind of photograph the area, and if I don't get the head, maybe you'll see the tail or something like that.
Mhm.
Propose
I'm happy with that.
Yeah, I'll pop up to Mount Ptolemy on Sunday night at sunset. Want
Mhm.
to join me up there?
Okay.
Scan with binoculars, because the binoculars, of course, be sure the sun is below the horizon, but scan with binoculars because they will gather more light and you will have a better chance of seeing the tail
Yeah,
or
for
the
sure.
head for that matter.
Yeah, for sure. I mean, any kind of optical amplification is going to help you. And Joe's quite right. Like the eye is very discerning, right? So there's your advantage.
Cool. Any other
Sunday,
questions about the Comet?
sunset at 7:30. No, 6:30. Sunset 6:30.
Thank you.
David, you mentioned you wanted to speak about one of the SIGs.
Yeah, we had to reschedule the beginners SIG, the getting started in astronomy SIG. It was supposed to be last Tuesday, but it's actually tomorrow. So we get to talk about. I guess we can talk a little bit about the comet. We can talk about, hopefully, talk about T Corona Borealis at some point. Lots of stuff, and I know people have a lot of new gear, so we can really talk about that. Kirsten always seems to be having something new in her bag.
Shopping again.
Shopping again, yes.
How many
Nice
people
toys.
are going to the beginner SIG this year?
It varies, but like when I asked for the list again, like I've been managing my own list, but I want to go to a centrally managed list, and I've got, I don't know, over 12, like maybe 12 to 14 people in the list.
Cool.
Great.
So it's a large number of people, and actually people do show up. So we often get like, I don't know, 10 people at the SIG.
And that's good.
Nice.
Yeah, but we sort of had different times and stuff, but we're getting better, I think.
Yeah, and we've met a lot during the summer. We've been trying to meet out at Cattle Point and things like that, and we had a pretty good session last night out at the VCO.
Nice.
So tomorrow night at 7:30. If you're not on the list and you want to be, just let me know.
Excellent. Kirsten
Mark.
had something to speak about. Are you there, Kirsten?
Yep. Thanks, Brock. Just I guess a reminder announcement about the meeting coming up on Wednesday, October the 9th, starting at 7:30 p.m. We have our monthly meeting happening up at UVic at the Bob Wright Center. It's in Lecture Theater A104. With parking available in Lot 1 across Ring Road. It's only about, I think it's $4 or $5 for parking for it. But we are fortunate to have a speaker joining us. We're going to do the format will be Chris, our president, of course. He will be doing sort of a 10 to 15 minute introductory remarks session and welcoming guests, and then providing any kind of announcements about some of the kind of the key highlights of events coming up. But then we have, after Chris is finished, we will have Brianna Kromp-Vowitz. She's a PhD candidate up at UVic, and she's going to be talking to us about the study of star formation and her work in terms of recent advancements that have culminated in the James Webb Space Telescope and how our understanding of stars is changing as a result of the information and observations coming from that. And she's going to be linking that with the birthplace of stars, the material and molecular clouds, and that whole context of star formation. So yeah, Brianna Kromp-Vowitz. She is, I'll just give a quick highlight. She's, pursuing her PhD in physics and astronomy at the University of Victoria, focusing on analyzing data from the James Webb Space Telescope to study galactic star-forming regions. And yeah, should be a great speech. So hopefully we'll get lots of attendees.
Sounds really interesting.
And don't forget coffee and cookies and meeting everyone afterwards up at the Astronomy Lounge.
I'm keenly awaiting this talk.
Wait. What's it? Alex, what are you gonna make?
Does anybody know if the Bob Wright Observatory is going to be open that night as well? I guess maybe nobody knows for sure.
I believe it is. I saw something about the open house events up at the center at UVic there. They've resumed. So hopefully it should be open on Wednesday night.
Yeah, they have resumed. They're canvassing for volunteers, so we'll have to just take it if it's there.
Yeah, I was looking around, and it looked to me like they were back at it for the fall term. I think from 7:30 to about 9:30, and they've been saying rain or shine. I think they have a little gathering up there if it's not suitable for observing. So. And yes, and Kirsten mentioned, that we'd be starting off with a few announcements of things. And, I've been thinking about this the last few days and thinking about some of the monthly meetings I've gone to, around the country. And some of these things, like I think we should speak, I or somebody else should speak at least briefly about the comet, because I think that's what's going to be on a lot of people's minds.
Yeah.
And but if you have anything astronomical to bring up, David, if you're there, you might. I'll be happy to let you give a little commercial for the SIGs and all that. And
sure.
So I think it's maybe a bit much to ask for this meeting, but in the future it might be worth considering having somebody do kind of a stars this month thing. And so if anybody is thinking that they might be interested in doing that, you should talk to me or Kirsten.
Brian wants to say
Thanks,
something.
Chris.
Question, how well advertised are these UVic events externally? I'm thinking about, for example, the astronomy clubs in the high schools. Do they get invitations or notice of the UVic events?
No, and that's a good idea. I guess we just have to figure out how to do that.
We'll find the contacts,
I mean, the main thing is, what what we've done in the past is put them on our website or in Sky News or something like this. And you know, I think we're just kind of in kind of a different world right now after the pandemic than we were 5 years ago.
Yeah.
You know, one of the changes being, you know, a lot more people are here for Astronomy Cafe, and things like that. So, so this is something I think we're going to have to work on in the next little while.
Yeah, well, I'd be happy to try and find the contacts for the astronomy clubs in the local high schools, and then I can refer them to the website if it's posted on the website.
Yeah,
so
it is there. Joe is really good about posting that stuff.
Good, good. Okay, so it's there. I can find it, send it on. Because
yeah, it's posted to
now.
it's posted to the website, of course, as soon as Kirsten gives me the information. And about a week beforehand, I also promoted on our Facebook group. So that's 600 people see that as an event.
Okay.
So there's some modest promotion. I don't go overboard. It's not really my job, but I try to handle the online stuff.
What about UVic students? In, you know, physics or astronomy or whatever they're taking?
I can speak to that a little bit. We have contacts with the Dominion Astrophysical Observatory that's very linked with the University of Victoria, as well as a contact at UVic and Camosun. And they are aware of the events, for sure. Like, they know about the monthly meetings, they know about our website. And so they are linked in to it. Yeah.
And something else, I've had this bee in my bonnet for a while. I've never really acted on it, but some centers, they put up one of those stands that you can get a sign shop, you know, where we, you know, put the, you know, Victoria Center and maybe our crest or something like that outside the meeting, so that when people come into the building, they know where to go. But that's going to involve a little work and expenditure of funds. So it hasn't been brought up yet, but I hope to bring it up one of these days. So we have that, so people can find where the meeting is.
So the other thing that happens on Wednesday, it's the peak of the Draconids meteor shower. So those ones that you were seeing the other night, David, they're so on your way in and out of the auditorium, take a look.
Or maybe go up to the rooftop.
Yeah.
Yeah, that's a good point. I didn't know when the peak was.
Head up told me afterwards.
It's no comet, but it's fun too.
Yeah. Okay, that sounds like a good talk. Margie, you mentioned that you had a telescope donation to bring up.
Yes, I will see if I can share my screen. Okay, close all screens, open presentation, close all screens. Okay, now share. Okay. All right, click on desktop one. Yep. Okay. Press share.
Wow.
No, that's not it.
That's still wow.
We say that every time. No, that's not it. That's just my screen.
No.
All right. Can you see that?
Yes.
Yes.
All right. A friend has I think it's about 30 years old, a Bushnell 450 telescope. Her son is now in his early 50s, and I think they bought it when he was about 12. So it has sat in their basement, sat in storage for quite a number of years. It's very rarely been out of its box. So that's what it looks like. It has a finder scope on it. It has a, what's that thing called? Just a second here. Oh, it has a Barlow lens, 3.0 Barlow lens. And it doesn't say how many eyepieces it has with it, but it looks as if it's more than one. So there's the telescope. Let's see. Finder scope, 5x24 finder scope. Oopsie. There we go. 1.5 erecting lens system. I don't know what that means. And a 3.0 Barlow lens. Alt as mount comes with it as well. It is metal and it is up to 5 feet high. And it says that it's good for the moon and planets, the largest planet maybe too. So my question is, do we want this? She's giving it away for free. Do we want this? Or do I donate it to, I don't know, a school or somewhere else that you would suggest?
It looks a bit like a department store scope, but probably doesn't have an aperture to really gather much light.
Yeah,
And
it could
the
well
fact
be.
that it mentions top line 450 power, that's generally a clear sign of.
Okay.
Yeah, I would
Any-
suggest you just put it on Facebook Marketplace or
Yeah.
Victoria Buy and Sell and to give it away.
Okay. Yeah, I think she said, I asked her how much she paid for it 30 years ago. She said she paid about $100.
Yeah.
So that
Yeah.
gives us an idea.
If I were her, I would give it away for free. Speaking of free, we also have a telescope project posted to our website. And it's a criterion for those of you who are old enough to remember. That was one of the early refractors. I put the link in our chat. I'm not going to go through it because I don't own it and I'm not involved, but I did post it to our website at the request of a member. And it needs work.
Okay.
So I just wanted to call your attention that free stuff and buy and sell stuff is on our website. Just to add on to Margie's pitch about telescope donations.
Right. Okay.
Joe, is that a place that it would be worthwhile putting this telescope or not?
You did.
I wouldn't be keen on posting such a modest telescope on our website.
I like that word, modest. Okay.
Well, yeah.
That's good. Thanks.
Sorry.
No, not at all. She has it and she wants to give it away, and
yeah,
we'll
it's worth
find
asking.
Sometimes those telescopes are called hobby killers.
Yeah.
Yeah,
because
that's one of the reasons. That's the source of my reluctance, because it tends to chase people away from astronomy.
Yeah, don't want to do that.
Hey, Brock, it could be converted into a solar projection scope.
Go right ahead, David.
Not that I'm volunteering.
No, just put some wires on the back and a white paper disc or something. A little cage. Okay, Dave Payne has some images.
Yay.
I happen to know. He mentioned them, and I know that I've seen some good ones. So.
Sure. Pull it up there. I was just going to share one, but in a little detail. But if you've been following the images I've been posting on Zenfolio, on our Zenfolio site there, I've been putting some lengthy explanations about star formation. So I'm keenly interested in the talk on Wednesday, because I've looked through, I've done a lot of research on the conventional understanding of how stars are formed. And there's nothing new that has come out recently, and a lot of the fundamentals are kind of out of date. So I've been taking pictures of places where stars are forming, along with the research, and trying to put it all together. And this is, hope you can all see this. This is called the Rotting Fish Nebula. LDN 251. And I think you can see the rotting fish.
Mm-hmm.
Here, there's its tail and its head. So what if you can imagine is that this fish is what is called a molecular cloud, where stars are formed. And it's mainly hydrogen in there, but there's really a dog's breakfast of chemicals in there, and a lot of which are not very volatile, and are solid dust particles. So these can be metals, or they can be various inorganic chemicals. They can even be organic chemicals that are very small. And that's what you're seeing, because the hydrogen itself is invisible as a gas. It's fairly diffuse, or fairly thin, but not as thin as the interstellar media that's outside the molecular cloud. And in this one, there's a bit of a wind moving from the left-hand side to the right-hand side of the object, and that's why you see this erosion patterns, and you actually see a little bit of a bow front coming around here. But there's some other interesting things you can, well, what you're actually seeing is those dust particles reflecting the light from all the stars that are around it. And what this does is it reflects, but is also absorbed by those fine dust particles. And that tends to warm up the outside of the molecular cloud. And what I mean by warm, I mean like 100 K, so minus 170 Celsius. Now it can get a lot warmer than that and get quite hot, up to 1500 if it's in one of those hydrogen alpha emitting areas. But this is not, this is just RGB as our eyes would see it, only gathered a lot more light than our eyes can. So you can see it's getting darker, and where it's getting darker, the cloud is getting is shrinking. So and that's a result of the middle parts of the cloud getting colder, because the light that's reflecting, warming up the outside of the cloud, can't get through the dust to warm up the inside of the cloud. And in fact, the reverse is happening at radio wavelengths and far infrared wavelengths. The heat from the center of the cloud is being emitted by the dust. We can't see that light because it's too long wave to see, but it's being sent out into deep space, which is only about 3 Kelvin of degrees. So if you can think of the flow of heat through this thing, it's warm on the outside, getting cooler in the middle, and then the dust takes that cold energy and emits it as radio waves into deep space. So in terms of the cloud itself, it's feeling the cold in the middle is sort of, it's reducing the pressure in the middle. So the cloud tends to flow from the outside, the cloud itself, towards those middle parts. And those middle parts can get so cold that all these other chemicals first freeze out, and eventually hydrogen begins to form on the surface of these dust particles. And these condensed hydrogen in the darkest places will aggregate to form the nucleus of what will become a star. So those have to aggregate enough till gravity starts to take over. And then in the latter stages of its growth, where it really accumulates mass, is gravity pulling in more molecules from the molecular cloud. So the oversimplification that you might read in How a Star is Born, it just says the cloud collapses due to gravity. Well, it's kind of true, but there's a lot of thermodynamics that are happening and fluid mechanics that are happening before that gravitational process happens. So these stars are forming inside the cloud. There's a couple of things I want to point out. There's a couple of galaxies that are obviously not inside the cloud, but we're looking through the cloud to see them. And you can even get a hint of some of those bright, hot hydrogen alpha emitting areas on that one and that one. And then here and there are what are called young stellar objects. There's one here. So this is a star that's in the middle of the cloud, but it's in its stage where gravity is making hydrogen in the cloud itself accumulate at a certain point. And there's a few of them in here. There's some you can see, and some have been identified by infrared telescopes that can see deeper into the cloud. But there's another one happening there, and this one's actually got a couple of jets known as Herbig-Haro jets that I'll explain at a different date. But what you're seeing here is basically a heat engine that's using heat from the light that's striking upon it to initiate the creation of stars. So there's one thing I want to show how.
So David, question there.
Sure.
Is the chicken or the egg? So do you need the stars to be able to create the conditions to create the new stars?
Well, you need the cloud to create.
You need the cloud,
stars.
but then it's collecting heat from existing stars.
Yes.
Here, the cloud.
So what I have been researching and focusing my attention to is what are called type 1 population of stars. So all these chemicals and the dust itself originated by supernova explosions.
Mm-hmm.
So that's where the chicken and the egg come in. Like the dust is quite essential to this mechanism of star formation. So if it came from supernova, which are exploding stars, where did the stars come from that created this supernova?
Mm-hmm.
That is a really tough question that I don't think is immediately apparent to anybody. So that's type 2 and particularly type 3 population stars, which were the initial stars that were made in the universe. Now, the type, one thing you'll notice is globular clusters. Now, globular clusters are not made this way because this way doesn't result in globular clusters. And so a lot of the globular clusters that we see in the sky and can photograph are come from outside the galaxy and were captured by the Milky Way at one point. And we don't see them, for whatever reason, being made anymore. And so I think it takes a lot of thought to figure out a pathway, which is what this is all about. You've got to get a pathway that is consistent to our physical laws that gets you from a cloud into a star.
Hey, Dave, I got a question for you.
Sure.
Have you ever come across an estimation of how many stellar generations have actually happened since things kind of got lit up?
I've heard various things, and people have tried to calculate based on the dust that's based on the molecular cloud, the amount of hydrogen that's around. I've heard all kinds of estimates. The most popular one is 90% of the stars that will be created have already been so.
So does that translate to how many generations of stars and supernovas becoming dust and more stars and those becoming supernovas and more dust?
Yes, that's where that estimate comes from.
Hmm. So any idea of how many generations that is?
Well, when I say generations of stars, I'm saying there's type 1, 2, and 3 populations.
Hmm.
Those are the 3 categories we put generations of stars. Like a big blue star only lasts hundreds of thousands of years, whereas a yellow star like our sun, well, it's midlife and it's already lasted 5 billion years or 6 billion years, something like that. So there's a big
Okay, yeah, you're right. There's whole different types of stars. Have you ever seen in any of your photographs a stellar disk kind of, it's still kind of a big broad pancake, but the stars lit up in the middle?
No, I haven't got the capability to zoom in that far to see the disk that will become planets. Is that what you're saying?
Yeah, exactly. Yes.
Yeah, no, I haven't even looked for it because I think it would be futile.
Yeah, I was questioning that a while ago, and I was looking at the Pelican Nebula, and I was just curious of scale, so I did the math on measured the size of the image, right ascension, to get a sense of the scale, and I worked out what it would be based on the distance out to Uranus's orbit. Like, so how big would a sphere as big as Uranus's orbit be in this image? And it was like a pixel or something. It was teeny tiny.
Okay.
So yeah, it can't limit the imagination, but hydrogen is a very sneaky thing, and because it's so small a molecule, it can fit in between molecules in a lot of substances, including iron. So what happens to that iron when it's infiltrated by hydrogen and that hydrogen starts to expand under enormous temperatures? Will it just what will the star do with all these other chemicals that exist? Will it create a disk out of them that will eventually form rocky planets? Like, there's a separation process that's going on somewhere there. But if you excuse me for just 2 seconds, I've got a molecular cloud I want to show you, something you can try at home and create one of these for your own. And I've just got to pick it up and I'll be right back.
Just gonna pull a rotten fish out of the fridge.
Yes.
This day's magic.
Anybody know how big these dust particles are? Like, are they like the dust that I pick up in my house, or?
So we have to look at this quick, and I'm not sure. Oh, there, you can see it there.
Yeah.
So this is a bottle. It's got, it was initially had just a tiny little bit of moisture in there because I wanted to make the air saturated. And I basically drank the water, dried it mostly out, and then you can see the molecular clouds expanding on me again. It,
You got it fuzzing, Dave. Can you?
Brock, can you make him bigger? Can you? zoom
Oh,
in?
is he not pinned? Oh, is he presenting? That's why.
I bet I can.
oh, there we go.
Green.
You can see that it's not, the bottle's not round, although it's getting rounder. You can hear it snapping back. But what happens is it gets cold in the bottle when I put it in the freezer. And that cold compresses the gas, makes it more dense. And then the bottle crushes to equalize the pressure.
He runs the top right of his face.
Is that not in?
It's because you're still presenting, Dave. It's showing your
Up to pin.
nebula rather than you.
Oh, okay. Stop share.
There you go. Now you're big.
It's almost back to normal. You got to be quick on your observations. But it's just you just have moist air in one of those flimsy water bottles and just stick it in the freezer, and you'll see that the air will cool, and inside the bottle air can't get in or leave, and air is just another molecular cloud. But if it's moist air, you'll see actually water condensing as a mist in the bottle, but also condensing on the outside, forming tiny little droplets that will amalgamate into larger droplets. So it's a fun little experiment you can do at home. Just pop it in your freezer if you've got room, and observe what happens. But it's roughly the same thing that was happening in that image I was showing you, but in reverse, because the cold is going through the outside of the bottle and on the edges of the bottle into the freezer, whereas in the dark nebula, the molecular cloud there, the coldest part is in the middle. So the contraction is towards the middle.
Cool.
Thanks.
Very good.
So Randy wanted me to show some of the options for the star party. Let me share that. Do you want to speak to this, Randy? I put it. Can you see?
So the first thing is St. Stephen's Church worked really well. And one of the things that was kind of invisible but really important is, had the weather been nasty, it has an indoor place that we can also do programming. So my vote would be that we continue our relationship with them. Next August, there's a very clear best weekend, which is August 22nd. Linda Clifford over there says, that rings a bell. She thinks there's a wedding or something then. And so we have to find out if that time is available to us. If it's not, then I don't want to be a dope and say, well, I don't know what is the second best weekend. And so I compiled this little table, and I really don't know. Like, I think we can all be agreed that the full moon on August 8th is a bad thing, because even lunar observers hate the full moon. So yes, nobody wins on the 8th. And then, so the other three possibilities, July 25, August 1, and August 15, all have issues. But I'd like to know, especially the people who are likely to come with their gear and are going to, the people who are going to try to enjoy the sky with their fancy equipment that night, which of the other alternatives would you hate the least?
Well, if I could just add one couple of things. The closer you are to July, the more you can count on the sky being clear.
Yes.
But also the closer you are to July, the shorter the night's going to be, but that's not really a big factor.
So you're saying the previous new moon, the July 25 would be your vote, Dave?
No, I can probably come on any of those and will come on any of those nights. I was away this past year, but I'm just saying the closer you are to July, the more chance that you won't get clouded out.
Right. That's a really good point. Okay, Brock, you're the sort that's going to set up a nice big telescope. Which one would irritate you the least?
Well, I mean, I'm on a thing like that. I'm not. So my telescope's going to be set up every night of the summer. So it's not like I'm counting on that for taking pictures or anything. It's more a chance to do something different. And so it doesn't have to be perfect new moon or anything like that. It's actually kind of nice for lunar observers to have a little bit of a moon to look at. And
yeah, if we're thinking of this being a semi-public event, I think the August 1st, 2nd would be better, having a first quarter. But otherwise, either of the two would be good. The first two.
Okay, and is it an issue that it's the long weekend? Again, it's Friday night, Saturday night. The long weekend goes to the Monday. Is that an issue for our community? Or is it actually a feature?
It's probably, I don't know, it seems like a very heavily retired group of people that probably aren't that worried about long weekends and stuff. But
yeah,
it's my general impression.
Yeah, long weekends can be an issue if it's a transport issue, but it's such a close venue that I don't think that's even a factor.
If 80 or 90% of our membership had young kids and we're all going to be away on trips to Parksville or something, then it makes it difficult. But looking at the demographics, I don't think that's probably.
Or couldn't make it this year, but what was the turnout for other people, like people coming just to
we had about
check it
80
out?
people each night. And the first night was more the regulars, and the second night was more the public.
Yeah,
it was a big difference. Like people were lining up at the telescopes on the second night, even though the sky dropped out on us pretty early. But the first night was when people could actually do some really good observing.
Yeah, well, it's
Laurie,
nice to have the kids and others to see the moon, but then transition into a dark sky for those that are serious about it.
August 1 is sounding pretty good. Okay, Laurie.
Yeah, I just wanted to know whether or not people were still considering that this would be something that really is for the members only, and that we would not be putting out a whole call for outreach and the public to come, or whether or not we wanted one night to be for members and one night to be for public, or both nights for the public. I think that makes a difference. I think there was a discussion about that. So
Laurie, I think as this is one of the big ways that we spend money in the club, and our mandate is for outreach, I think if we closed it, that would be problematic. I think this really has to be considered primarily an outreach event. Again, I'm not an old timer. I'd love to hear what other people say.
I think it needs to be both. And I don't understand why you're considering August 1 too. July 25, 26 would be the second choice, an obvious choice to me. They're both new moon weekends, and there's enough dark sky July. That's late late in July. There's lots of dark sky to work with. I mean, obviously, August 22nd, 23rd is ideal, but if there's a wedding that night, fine.
I would take that one too, Jill.
Yeah.
Okay, so it's not a problem having the shorter night for the people who like the white fuzzies.
Well, no, this is not Mount Kobo, where the dedicated paparazzi go. This is just a regular old star party that we want to go in and meet people and observe a little bit.
Yeah, it's also not uncommon for the early part of the evening for the public, and then most people kind of disappear after a period of time, and then people can just get on with the imaging after that. And those that really want to image kind of push off to the side anyways. They're not as in the public view.
I guess that early July, I haven't really looked, but it's unlikely we'd have even Saturn or anything popping up till very later.
Is the 29th part of the, wondering if that's part of it might be part of that long weekend.
Yeah,
and,
the next weekend is Santa Fair, and
so that's why it wasn't on your list.
That's not an option. Our biggest outreach event is happening on Labor Day, and so the following week is just not an option.
Okay.
May I just add that I don't know what conflict there is with the church, and presumably they would know and you would know with them. But since it's the best, I would maybe unpack that it is in fact a conflict, because most people are not married in the evening in a church, and they don't usually have the celebration at a church.
Yeah, I mean, this was just an offhand remark and saying we will talk about this, and I'm just preparing with the arguments. But it's a very good point. Like, if it's just that they're going to need it Sunday morning, we pack up really quick on Sunday morning. That's not the problem. So if it's just a Sunday morning thing, I don't see that being an issue.
Yeah, that's a good point. And if they do want to use the field as an event, we'll tackle that problem if it crops up.
Yeah.
Weddings tend to be more Saturday, though.
Exactly.
Anyway, I again, there will be more certainty soon. Last year, we didn't know that we didn't have Bright Angel Park until, I don't know, till February or something. We really thought that we had been such good citizens the year before that they would continue the exception. And then they said, nope, no camping, that's it. And that's when it was only after that we contacted St. Stephen's.
Randy, one other item to consider is you do want the 6-year-olds up there, because how many of us got captured by this silly hobby when we were about 6 years old? So I think more of them will be around on the 25th as opposed to the 1st, because on the 1st they all head for Parksville and the beach.
Okay, so I'm hearing more votes for July 25.
Yay.
Yeah. There you go. That's what I needed.
Okay. There was one other thing that I forgot to write down, and I could only hear someone talking, and I wasn't sure who it was.
Natasha.
Natasha, okay.
No, it was Shaunik, actually.
Oh, okay.
Okay, sorry.
Go ahead.
So, Brock, are you referring to the coloring space item for the agenda?
I don't know. I was making a note and somebody brought something up early in the meeting and said they had something to say. Okay.
Yeah.
Go ahead, Natasha.
So thank you very much. And this will be brief, but I wanted to let people know about a collaborative event. I want to share my screen. I'll just pull it up. So this will ring bells to Gary Seddon. Hello, Gary, and Joe Carr. So about 2 years after the International Year of Astronomy in 2009, we worked with the woman who looks after public outreach at Chandra X-ray Observatory, Kimberly Cowell, who is a scientist herself and has done a lot of interesting work around soundification of space imagery. Anyway, so she was fascinated by my late husband's work called the Organiverse Portfolio. And she thought, how about we collaborate on an exhibit where we juxtapose some of Henri's paintings with images of space. And so Henri said, that sounds like a great idea. And so the Organiverse portfolio is comprised of 100 paintings done in watercolor, and each original painting is only 8 centimeters in diameter. And it's all done dot by dot. In 1972, when we lived on the island of Madeira and in Morocco. And so she just selected these 4 images and put them next to images from space. And this website has been up for many years now, but it survived a complete redo after they did an upgrade on their site. And so you can scan through these examples. This is sphere number 16 out of 100. And so she was evoking imagery, selecting imagery that evoked the Organiverse artwork in some way. And you can see some of these images are quite old from the astronomical point of view. And if you click here, and I will put the link to this site in the chat box. So this is the next page, and she's talking about, color and how we think of it, and how in astronomy colors can be extended far beyond the range we can see. So she's giving a description here of how they color images. And there's one thing I wanted to show you briefly here. This is a video that actually Joe Carr put together for Henri's Vimeo site. And I'll just show you a quick excerpt. I did get a message earlier that my internet connection is unstable. So hopefully I'll just play a few introductory minutes of this. Let me know if you can see it all. So I'll stop it there, but just so you know, Henri was a color master, and the whole story behind the Organiverse portfolio is the birth of color. So at the beginning was just the blues, and then he integrates the other colors of the rainbow. So
So
that's
these on canvas or
these are all watercolor on
paper?
On
Yeah.
paper, that's right. So I want to go back now. How do I go back to the main site? Bear with me for a minute. How do I get out of Vimeo?
Just click on the tab on the top of your browser, Chandra.
Yeah, the first tab, Natasha. It says Chandra Resources Coloring.
That's it.
Okay, thanks, Joe. And then here we talk about Henri's philosophy of this work and the pointillism. And then Chandra, they've put in descriptions of how color is observed and referencing the science behind all these images. So that's really what I wanted to share with you. And you can take a moment. In a minute, I will post the link in the chat box. And Gary also did a lot. Gary Seddon did a lot of work when we had the exhibit at the Bay Center. And in those days, he was still up at the observatory and took the original artwork scans and created the video that was on display at the Bay Center. But the purpose of showing this is just another example of public outreach and how an interdisciplinary, we have artist and then we have the science. And I thought it's just a nice way of sharing with the general public. And if you ever get a chance to browse around the Chandra site and some of the work that Kimberly does, it's really quite fantastic.
And Natasha raises a good point about this being another form of outreach. As a matter of fact, I have copies of all those videos that we created and showed on the big screens that Natasha arranged. And they're very, very good for outreach because they're quite colorful and they're moving. And it's good stuff if you ever want to consider it for anything that we do. They have the NRC logo on it, but I'm sure they'd be fine with that.
Yeah, they're actually all posted to our YouTube channel as well.
Oh, they are? Okay, great.
All IYA 2009 videos are on there.
Oh, good, great.
Oh, that's good to know. I didn't realize they were still there, Joe. That's great. Okay, thank you very much.
Thanks, Natasha.
I think Lori has her hand up.
Oh, Lori, go ahead.
Yes, I just wanted to ask Natasha about things like copyright and being able to show them in the auditorium up at the center. Like what kind of permissions and accreditation and things would we need to have from you?
Yeah, that's a good point. I think when we were at the Bay Center, we had signage next to the video screens because all of the images are copyrighted. I hold the copyright now. But more than happy to share them as widely as possible as long as that connection is made.
Okay, thank you. I think we'd be really interested to have something up at the center. I think we could certainly work with some of that.
Yeah,
Yeah,
great.
that'd be great.
We did
Thank
actually
you.
have an exhibit up at the airport too. Remember, Joe and Gary? We had the screen
And
Yes.
at Mayfair and at Mayfair Mall.
And at Mayfair Mall too, yeah.
Yeah, you covered a lot of ground that year. Thanks to you and many of our volunteers.
Well, Henri would be happy to know that the work is still being shared and appreciated. So, yeah.
Did it have music accompanying the video?
Actually, that one that Joe put together has the soundtrack, but the original artwork, the original version, did not have any sound.
Yeah, we didn't put any sound, I don't think, in the public display ones because we were there talking to people. We didn't really want clashing between, in the case, like we were in public spaces where mall music was crashing in on us and stuff like that. So we had to be cognizant of the environment that we were in.
Yes, and I think Henri's always looked at his work more as in a contemplative exploration, almost a meditation. And so I think for the short video, for the Starry Night version, then it was kind of fun to have the music.
Very nice.
I had a question too, Natasha. First, sorry, I thought the question was who had made a point for the minutes. So I did have a suggestion, just a vague idea. Of course, you know, I really appreciate the Organiverse. Also, I believe it went up to space with Chris Hadfield, right? On a
Oh, good point. Yeah, I forgot about that. Yeah, Chris was a friend, or Henri was a friend of Chris, and when we first met him when we were living in Vancouver, and we did a collaboration with the Vancouver chapter of RASC, and we was with our Circumnavigators Club, and Chris came out and gave a fantastic talk at the planetarium. And there he met Henri and learned about Organiverse. And very long story short, when he was, made commander, well, first when he went up to the space station, he brought a memory stick with all 100 amandalas, as they're called, with him. So they've been up there in space, going around and around. So Henri arranged for Chris to become a member of the Circumnavigators Club because, of course, he qualified. Because to be a member, you have to
anybody.
you have to circumnavigate the world in one direction, crossing every latitude, every meridian latitude. So he got a big kick out of becoming a member. In those days, he was working as director of operations in Star City in Russia, but he was over in Canada for a while.
So the suggestion I had, or just an idea when I was watching that, I thought would be so interesting, would be the possibility of a talk, maybe even linking to the Organiverse, but on how to read color in the stars. I know a lot of experts know how to do that, but it is quite interesting, isn't it? Even what we're just looking about, the star formation, about reading color when you view the stars and what they mean, the new to the old. Just a suggestion.
Yeah, and Kimberly is very approachable. She might even be willing to do a talk about that at some point. She's based in Rhode Island. Well, she works at the Harvard Smithsonian, Chandra, but she's very, very keen on sharing, particularly sound in her case as well, the sonification of galaxies and whatnot. But she also talks about how astronomers interpret their images through color.
I think this is a great idea because kids ask, why is that star blue and why is that star red? And we need to be able to answer that.
It's the temperature. It's a thermometer.
Yeah, we know what it is, but we need to be able to explain it to the kids.
Yeah.
But you're right. I guess a thermometer is one way of saying it, Dave. You're right. But putting it in kids' language, I don't know if all kids would understand thermometer. But anyhow, whatever. It'd be good to have that talk.
I can quickly
please release the screen. Peter has stolen the screen and we don't know how to get rid of it.
Yeah, I wanted to quickly put up a page
as host, Randy, you can punt him if you want.
Oh, yeah, there we go. Stop persistent. There you go.
Okay, just quickly.
Kevin is all powerful.
Okay, so this is Kimberly. She's written a few books and things, so she does have her own website, but I think if she were to give a talk, it would be in her capacity. This is her title. She's a visualization scientist and emerging tech lead. That's her title at Chandra. So she's done books on light perception. She's got one of Henri's paintings in this particular book. So here's her business on sonification. She's got an interview with NPR. Anyway, she's very articulate, very generous with her time, and a lovely person.
Kirsten, I think we have something that we can get you.
Okay. Any other questions for Natasha? Does anyone else have any discussion points or things that they want to announce or bring up?
Actually, I think Kevin and Kirsten and I probably can just have a little bit of a report from the Hill. We
Oh, yes,
actually
about
had
your, yeah.
we actually had our first fall session last night, actually. So we were all busy doing different things, and I know Kirsten was out bagging more double stars, and Kevin was out looking at different things like Saturn and stuff. I was on an imaging mission for T Corona Borealis, and yeah, it was a lot of fun. Kirsten, what was your favorite object from last night?
I was fortunate. I managed to, well, I got the double double of Alcor Mizar. I knew it was a double, but I actually managed to split that double and get the 4 in my scope last night, which was great. And I got I got a couple Messier objects. One that I got 103, which was a bit elusive for me. It's kind of an open cluster in the constellation of Cassiopeia, but and I got another globular in the Hercules area, not M13, but another globular that I was able to track down. It was lovely, beautiful skies last night. But probably my favorite was a bit of an accidental find. It was a double called Miram. It's on the RASC double star list. I'm doing the RASC double star program. It's 110 objects, targets to find. It's seasonal, and it's Miram. I saw it on the list, but then when I was looking for M103, and on my Sky Safari, I was kind of looking at the mapping, and then I saw in the constellation of Perseus, I saw the star called Miram, and I'm like, oh wait, that's one of the doubles on the RASC list. So I was actually able to see the star visually because it was actually findable visually in Perseus, just up from Murphak, and it was an amazing, beautiful little double star.
I was really
orange, and
impressed.
red.
I had to look it up when I got home, and I saw some sketches and photographs of it, and the gold component is huge compared to the little blue component. So that's remarkable in itself. I kind of like it when they're disparate sizes because it makes them look quite unique when they're paired. It's a nice pairing.
Yeah, very, very beautiful. So yeah, last night was a fabulous scene.
Nice.
What about you, Kevin? What did you like the most?
Well, I like seeing the two asteroids or draconids.
Oh, the meteor.
Oh, right. Yeah,
two-
yeah. I accidentally caught those, but you saw them visually, didn't you?
Yes, I did. And I got to look at Saturn through mine as well as the 10-inch Dobsonian, and Reg put a really big magnification lens in that, which really made it a very unique view, I gotta say. And then I was chasing some of the stars in the Southern Cross, which were a little challenging because they were virtually straight over my head. So I was on my knees trying to look through the viewfinder, which is not the most comfortable position, but it was still a fun night. So
yeah, it was a lot of fun. And Reg and I just kind of looked at each other when we realized that everything was actually working inside of the shed, which is, it's not that it's remarkable, but yeah, everything just happened to work and nothing was broken for a change. So it was a lot of fun. Well, Michael, you took some pictures that night. Oh, Michael's disappearing now. Yeah, I'm trying to think about who else was there. Michael, did you take some kind of landscape shots or nightscape shots?
Actually, I went up with the idea that we were going to see some aurora, and
Yeah.
I was hoping for May 10th times two, but actually, none of my shots show that aurora, but some others did see it
I think
apparently.
Susan caught some. Susan, are you there?
I just needed to unmute. Yes, I'm here. I don't know how to screen share, but I've got one shot that's quite lovely.
Oh, okay.
I went down to Cordova Bay.
It should be pretty simple. There's a share button near the lower part. It's green, I think.
Okay.
And then then if you pick your own screen, then we should be able to see it.
Oh, I don't know. I have to get the photograph first, don't I? Okay, here's the photo I've got.
Okay.
And does anybody see that yet?
Yeah, I do. I do. Wow. Green and kind of pinky stuff in the middle, right?
Could be.
Yeah.
And I don't know if let's see, how do I get the other pictures? Well, anyway, that's the one that was the most impressive that I took. So
that's after you left the VCO, right?
Yeah. It was about
cool.
9:30.
Yeah, nice.
Beautiful.
Now, how do I get out of here?
You can do an end share. There you go. Wow, look at that. You shared and everything. You didn't even know how.
I've never done that before. Thank you.
Well, you have now. Yeah, Thursday. I think Reg was intimating that if Thursday's clear, come and join us up on the hill.
I was awake at about 3, so I went out at 3 to see what was happening out there, and it was lovely, sparkly stars, absolutely lovely. But all I got was just a few little wispy clouds. I couldn't get any color at all. I think I missed the timing. I was a little bit too late. I went back to bed. But the stars were beautiful. I saw Jupiter and Mars and the Pleiades, and like everything was just sparkly last night. It was lovely. So nice to be out.
Evan, can you hit decline there? Before we go, I'd like to remind everybody there is no Astro Cafe next Monday. We've canceled it so that everybody will go out and look at the comet, of course. And then on the 21st, Brock is our host again.
I think Lori has her hand up again.
Oh, Lori.
Sorry, yeah, Brock, I sent a little note to Brock. I just wanted to ask, just at the end here, if there's anybody else who would like a calendar or one of the other publications. As I mentioned a couple of weeks ago, a last chance. I've actually ordered 35 calendars. I have 29 that have been actually asked for or I requested. So I do have a little bit of some room. If there's anybody else that would like a calendar, please let me know. The other things are going to be ordered just a little bit later because they come in 2 different packages, and I didn't want to get everything all mixed up, as what happened a couple of years ago where things just didn't work. So I'm doing them as two separate things this time. So just let me know. Just email me at roche.lori, Lauri, @gmail.com. Thanks.
Thanks, Lori. Okay, well, thanks everybody. That was a good session. Unless there's anyone else, have a good night, and we'll see you in a couple of weeks.
Thank you.
Thank